Jeff and Academy. Could you guys please give a quick introduction about yourselves and your research focus?
My name is Shudong Jia. I'm the Associate Dean of the College of Engineering and Computer Science. Before I came here, I was also professor at Cal Pomona. You may know the school over there for 20 years, 22 years over there. I think that's the one right now.
I'm Paul Weiss. I'm a nanoscientist at UCLA in chemistry and biochemistry.
To be here with us today.
You want me to start first? Okay, my area is in transportation. Traffic in LA is a big issue, right? That's my area. So before I came here, I was, a kid like you, playing a lot of games, computer games. At that time, I just say, hey, I love a computer. I want to be in major computer science. I was not lucky to get in, so I was involved into some kind of major we call it transportation, traffic. So that's the area I was involved. In China, you have no choice to select your major. You have to be assigned. So I was assigned to be in that major. Even though at that time I was not happy with it, but I have to be adaptive. So I learned my way to be a, bachelor, master. So I love now transportation. At the end, transportation is not even of the game. So when I was a faculty member, transportation is only one area. I also apply some techniques, like computer techniques into transportation. So I love to use the technology to be in the field. So just give you advice. Even though sometimes you don't love the stuff you are doing, try to survive first. And after that, you find a way to be back. Now, I'm the associate dean of the college. I manage all of the majors, including computer science. The professors over there trying to listen what I'm asking them to do, right? So now I'm the one to learn the subject and to be adaptive, and then I can survive. So that's kind of advice I'd like you to know. Be with you when you have something you don't like it.
So I think I may be the only one here who remembers the original Earth Day. And there's still a mark around my bedroom door from when I was a kid from that day, which was a long time ago. I've changed my fields several times, and actually the advice section of the last panel I really enjoyed, and the way I would describe that is don't be afraid to change your mind, and let other people change their minds too. When I was an undergraduate, I went to college very early, and I would just look for whatever courses I was interested in. I didn't care about if I had prerequisites. I would just always be willing to go and do the work and ask the professors, go to YSLL, what do I need to be able to take this class? And so my actually very first computer course was a graduate AI class, because that's the only one that fit in my schedule as a freshman. And I just sort of ripped into it, and in every other class I didn't worry so much about grades, sorry for burning through here. But followed what I cared about, and that led me to be willing to work much harder, I think, than people who were in a very regimented program. I got interested in how electronic structure and chemistry were coupled with sort of the detail, but I followed through my PhD until I realized I didn't like the day-to-day of what I was doing in the laboratory, and changed completely and learned about semiconductor physics at laboratories and surfaces, and then the field of nanoscience was just beginning, so I ran and helped build what was for many years the best microscope in the world, and was the first one to move atoms around. And so I still had this goal of looking at, chemistry and where the electrons were and where they weren't. And I thought that would take my whole career, but then and that was kind of a crisis, and I needed to think of what else to do. And that progression has continued where, now we take on problems like, what you heard Wilhelm talking about in his project. In the fundamental science part of our laboratory, we try and understand how and why nature uses such poorly conducting molecules to move charge around, and look for inspiration for how we might do that to use a lot less power in these microphones and the laptops and the cell phones and so forth. So I'll stop it there.
Thank you. I was always interested in how things works, motivated by my older brother. I knew that I'm interested in engineering. I ended up choosing mechanical engineering as my major for undergrad. I did my undergrad back home in Iran, and after that, I was interested to continue my grad school. I moved here and I started my master's degree. I wasn't sure right away jumping into PhD. I decided to do master's to see how I fit, if this is what I want to continue. At some part of your career, if you come up with those questions, don't be worried. It's a time to actually to reflect, to stay for a moment, to think about what you want to do. And during my master's, I got basically more involved in research, learning about materials, how polymers works, what are the monomaterials, and that was basically a bigger motivation for me to continue my the school and start basically my PhD, where I combined 3D printing, what we call nanoparticle-based 3D printing, and a little bit of material science towards different applications, and that's how I'm here.
Thank you, guys. So many of our members in the audience today are prospective students with long schooling and careers ahead of them. In the next few minutes, I was hoping you would be able to share some advice with the audience members on how to approach their future studies in the sciences and engineering. What kind of field should we be studying? If I want to make the biggest impact in the next decade, what should I be doing?
Things on the engineering side, what do you think? Clearly it's engineering, right? So what's the fundamental capabilities that engineers should have? Solving problems. You solve problems. You're trying to educate yourself to find a way to solve problems. If you are in that kind of field, feeling like that, so this is the area you would like to do. AI is a buzzword right now. AI changed everything. In the past, we used statistical technologies to do business, to solve problems. Now, everybody talks about AI. So as an educator, I'm looking at AI as one of the opportunities to change our educational system. All of the courses you are taking right now are not AI-based. So let me ask you, how many people playing ChatGPT? Everybody raise their hand. Everybody almost, right? So what do you find from ChatGPT? The way how to ask, right? You ask simple questions, they give you simple answers. You ask complicated questions, they give you some kind of answer you want. That triggers us to think how to educate our future kids in this new environment. In the past, what do? We learn the subject, we learn the knowledge. We never think about how to ask. You know, ChatGPT gave out another dimension. Not only need to learn the fundamental part, in the future, we need to know how to ask. So that's why we call it new major, prompting engineering. If you look at if you look at Google or some other places, prompting engineering is the way to do. So they change the people's thinking after we have ChatGPT. So you guys are young engineers or young scientists, future's yours. Think about, how to be adapted in this new environment. As an educator, professors, we are thinking about that too. Right now, people think about, you know what? Students using ChatGPT for cheating in the midterms. We use ChatGPT to do resume refinement. We use ChatGPT for almost everything, right? So we're thinking to block it. My advice, trying to be adaptive. From student point of view, you learn how to use it. Hopefully you will be the master of ChatGPT. So 5 years ago, before the ChatGPT was on, I love my part. I use a natural language processing before that time. You remember I said my love is in computer science, coding. I love that part. I developed my own computer games when I was young. Right? Now, a lot of people, including my kids, they love playing games, repetitive, trying to find your own game, develop your own game. That's the kind of the master you will be in the future. So bottom line, AI is on the way.
Yeah, so maybe I'll start a little more upstream. Find what you're very excited about and can't wait to get out of bed in the morning to do. And you can start now, right? You can go read popular science articles and follow the links in the literature, scientific literature in those. It'll seem like a foreign language at first, but as you get deeper and deeper, it'll start to make sense. I teach a class of the top 40 science and engineering freshmen every year at YSLL, and starting in the first lecture, the students go into the literature the last year, and then they start to explore what they're interested in. I have them go to seminars. Again, it's just foreign language immersion, like when you take a foreign language class in middle school or high school. You will understand more and more as you go. When you go to college, as you heard from Professor Goodman, just start going to seminars. Most undergraduates don't do that, and then as you see who the hosts are, who's speaking, go and go to the office hours and ask for more. Ask to join a lab. In that class, I got every single student in a research laboratory by the end of 10 weeks, by learning what they're interested in and connecting them to labs around campus. And so don't be shy about that. When you go to college, you have this enormous opportunity that not so many undergrads get, that early on. Don't wait. And again, you can change your mind later. You may find that the hands-on part of that laboratory experience is very different than what you learn in class. It is. Sometimes it's a lot more fun. Sometimes it's not great. I lasted 3 hours in my first research position. Didn't like the smells. I won't say that. You can guess what kind of chemistry it was. And then I went in, left that lab, and went and actually worked on artificial skin, something that I didn't do again for decades, and then I worked on a related project, kind of amazingly. So, find those things to do, and then change as you need.
I would also mention, follow your passion. That's what it's going to be do. Every day it's going to drive you towards your success. So find what is your passion. And it's perfectly fine to try a couple of things. And the other thing that I would add is be open to learn. Doesn't matter what major you pick, you start. Be open to learn about things, because the nature, the way that we are basically proceeding to future, you need to develop and have those skills that can work on multidisciplinary projects, work with people with different expertise on different teams without having or being expert on that field. You need to develop and work on those skills from communication all the way how to be a team player and have that required skills.
Thank you guys, very insightful. I would like to sort of stick to the theme of advice for another question. So many of the students in our crowd are high schoolers, and it's been a long time since you guys have been in high school. You've made a lot of decisions that have changed how everything plays out. What would you do differently if you could go back to high school?
Okay, that's a good question. Let me think about it. I was 16 at that time. I jumped 2 grade. I went to the college. It was too early. At that time, I was 16. Everybody's just 18, 19 at that time. I was a newbie, so young, right? And then people look at me, you're so so young kid at that time. So I wish I have 2 more years to wait so that I can be more mature at that time when I go to the college. So that's kind of what I'd like to do. Jumping too early may not be a good choice. Yeah, that's kind of my lesson I learned. But another part I thought, you know what? You have 2 years early, so you have 2 years early of learning some subject. So that's another angle. So I'm thinking, bottom line here is enjoy your moment.
I think, well, two things. One is, I wish I had sort of looked more deeply when I was in high school. I didn't get challenged very much, and actually left early also. I went to college at 16, and I knew I was going to step up in terms of challenges and opportunities there, and so it was a very dramatic flip. But I wish I had started that in high school. I had extra time, and I could have used that. I lived in a college town. There would have been an opportunity to go and work with someone there and really get started early. I know many of you are right around this university community. There's an opportunity here as well to go to talks, to see what people do, to start exploring what interests you have. Even if you're not going to be in a lab yet, you can start seeing what it's really like, instead of what you read in a textbook that another 100,000 students around you are also reading.
To be honest, I'm happy with my high school time because I enjoyed it. So, and I would say definitely I was a good student, by the way, and I think pretty much I was active, lots of extracurricular activities, hanging out with my friends, campings, lots of them. I miss those days because it doesn't happen often now. Definitely, as you are basically exploring your path, identifying your passion, who you are, answering those core questions that comes up, and we all have in mind. Those core questions are going to basically show the road to you and who you're going to become in the next 10, 15 years. So thinking about them, don't be afraid of facing with them. Definitely, that's what I would, if I go back, I would do more. So that would make my next phase of my career or education would be easier for me. I wouldn't have to deal with some doubts that at certain ages or at certain stages come up anyways, whether we like or we don't.
I'll add one more thing. It is much more stressful now for high school students and their parents than it was even, when our children went to college. We sort of applied around, and I didn't even visit anywhere because my parents were sick of visiting schools with my older brothers. They, sent me in a car with my only high school classmate who was going to the same school. The level of stress is chill. We get to see it with Rohan and our neighbors and our nephew. It's all going to be okay. It doesn't actually matter that much where you go as an undergraduate. Just do well, and that'll open opportunities to go to whatever graduate school or professional school you want to do. And so, enjoy the time. Be a high school kid. And if you're a parent, let your children be high school kids too. I'll stop there.
Thank you, guys. So I want to slightly shift gears, and I want to ask a question specific to each of your domains of research. So starting with Dr. Weiss, but if the other panelists would like to comment as well, what do you think the biggest impact of nanoscale innovations will be in the coming decades?
Yeah. So one of the special things about nanoscience, and I'll talk about this in the closing remarks, is we came together as a field. None of you have had a high school class in nanoscience. The field didn't exist when I was a student. We came together from physics, chemistry, biology, engineering, materials, medicine, toxicology, and we had to learn language skills in order to communicate. We took on each other's problems. We adapted each other's tools. We invented new tools that didn't previously exist to take on those challenges. And we actually uniquely developed communication skills across fields. So, for instance, the BRAIN initiative under President Obama that came from nanoscientists, actually put a panel together and then led the technology roadmap for that. It did not come from the neuroscientists. In fact, we had to keep them, we're not recording this, we had to keep them from killing it. Right? After that, there was a precision medicine initiative that probably none of you have heard of because it was viewed as a failure, because the people in the field said, just give us more money and we'll do what you want. And so there was a third and final initiative on microbiome studies. And so we were asked to come back as nanoscientists and lead that as well because we were inclusive in bringing in that case, people from oceanography, soil science, gynecology, chemistry, engineering, and so forth, but really pulled in everybody who understood that led other countries even adopting that initiative and companies starting new divisions. So I think the impact of neuroscience will be much bigger. Looking at those opportunities and then coming up with plans and schemes to address needs.
Thank you. So moving forward, I have a question for Dr. Saidi. 10 years ago, a basic 3D printer cost $3,000. Today, we can buy a similar device that fits on your desk for less than $300. 3D printing has come a long way. Do you think 3D printing will continue to impact different fields of engineering, and how far do you see it going?
That's a very good question. So 3D printing has been around since 1980s, but the past 20 years was basically the boom and where the industry adopted and basically we started using 3D printing. And yes, of course, right now, as of now, we are talking, it's impacting a variety of disciplines in engineering, from helping us to build massive rockets all the way to making basically printing in a cell size and so on. And of course, we are moving to basically the era that 3D printing is basically, we are integrating with AI as it's impacting other areas, 3D printing also. And it's part of what we call fourth industrial revolution. So helping us to improve and make things in a better way and cheaper, faster.
Thank you very much. Lastly, I have a question for Dr. Jia. Over the past few years, AI has become exponentially more complex. Recently, we have seen tools like ChatGPT skyrocket in use. Where do you believe the biggest bottlenecks will be for the future development of tools for AI?
Good question again. AI, right now, we have two types of users for AI. Like a normal user like you, like me, right? So we use some ChatGPT. That's the interface between the hidden human being-like machine down there and also the user like you. So that's one type of users you have. Another type of user, kind of developers. They're trying to use AI, ChatGPT, large, modeling, here and there to develop some applications. So at this time, young kids like you, trying to enjoy the moment, trying to understand how AI works. That involves the mental shifting. That means right now you learn the one from the books, from Google, and later on you will learn from AI. So that's kind of the key shift. This is not easy shift. We don't know what's our future, to be honest with you. AI gives us endless possibilities outside. It's kind of scary, to be honest with you. As an educator, I just mentioned to you before, all of the existing courses and also lectures, modules, everything we are doing are based on past knowledge. And the AI gives us another option to say, the knowledge you got is the one side. You have another part of knowledge you can get from AI. how to empower AI opportunities for your career. That's the future. I think it's tough. I hope just be prepared. That's what I would like to say. Thinking about it, play with it, trying to be adaptive. That's what I would like to ask, to give a suggestion on that.
Thank you guys very much. In the closing moments, I would like to open up a short, broad discussion about the future of sustainable engineering and how artificial intelligence will impact it. As per the title of this section, which is Materials for a Sustainable Future, with the integration of AI into materials engineering research, what are the potential advancements that we can expect in fields such as aerospace, healthcare, and renewable energy?
You want, you guys? Oh, I got to start. I just continue on this subject, right? One of the key AI development is we call it generative AI. Maybe you heard of that? You know, ChatGPT is one product of generative AI, not normal AI. When I was a PhD student at the time, my dissertation is on AI. Even though my area is in transportation, I use AI, techniques inside of my application, transportation. So that's kind of the AI, that's a traditional AI. And now the AI we're talking about is we call it generative AI. Check it out. There's the way to show, how to think about some kind of subject you're working with. Another part I'd like to say is that you have to be prepared for something we call it the new change, the new way of handling business. When I was a faculty member, I'm dealing with a lot of research projects. At that time, we use statistical analysis here and there. Now, statistical analysis is not a new subject anymore. Everything about deep learning, neural network, right? Maybe you heard of it. I'm not sure in high school. Did you touch base with deep learning? Maybe you haven't. But this is the kind of the change you need to be prepared for. So that's what I would like to say. AI is on the way. AI is not a virtual thing. AI is the one which will change our daily life. 10 years later, maybe 20 years later, yeah.
So AI interpolates, but it fills in the dots between known data sets. It doesn't create new ideas, and it doesn't generate sort of out of bounds materials. So I think there remains incredible opportunities for creativity. Once those are identified, then presumably help us explore that space beyond that we left in those new developments. But I think there's still an awful lot of room for science and engineering innovations that will particularly impact sustainability and healthcare.
Conventional ways of making materials and synthesizing them is very costly, and it takes lots of time to come up with new materials to meet the need that we need today, right? So if you look into the material design histogram or paradigm, we have come up with the three prior stages of starting with experimental approaches, then theoretical, computational, and now the AI is helping us basically using data-driven approaches to accelerate this process, which helps us to design and build new materials in order to build better and basically more advanced technological tools that we need.
Thank you, guys. I would like to thank our wonderful panelists for their interesting insights and on the broad field of engineering. Thank you all for listening, and have a great rest of your evening.